Today we will be discussing another train problem. So we're given that two trains are traveling between stations A and B, and one train leaves station A towards B, and the other train leaves station B for A. So that means that the two trains are traveling opposite to each other in the opposite direction, and the distance between these two stations is 1000 miles. And we are given that A is traveling at 60 miles per hour and B is traveling at 40 miles per hour. Okay. Now we're given another twist in this problem. At the same time that the trains start from the station, a bird starts to fly from the front of A and A towards B, and it's flying at 80 miles per hour. So given that once the train A starts from the station, a bird starts to fly from the front of A towards B at 80 miles per hour, and it flies till it reaches the front of B, and then it reverses course and goes back in the opposite direction towards A, and it continues this process until the two trains cross each other. So we are supposed to find out what is the distance that the bird traveled. Okay, so let's visualize this problem. Let's say these are the two train tracks and the two train stations. Okay, let's say this is station B and this is A, and the distance between these two we are given as 1000 miles. Now we are given that A is traveling towards B, train A is traveling towards B, and let's say S of A is equal to speed of A is 60 miles per hour. And we are given that train B is traveling in this direction towards A, and S of B is equal to 40 miles per hour. We are also given that there is a bird. Let's say this is the bird, and it starts to travel from the front of A as soon as A leaves the station, and it travels towards B at 80 miles per hour. So let's say this is the bird per hour. So let's visualize the bird here a little bit. Okay. Now one way to, and we are supposed to find out what is the distance that the bird traveled. Okay. So let's say the two trains cross each other here, and we are supposed to find out what is the distance that the two trains traveled. Okay. Now one way to think about it is like, let's say the two trains cross here. So in the first pass, as soon as the train leaves, the bird starts to travel. So it goes here. This is the distance till it reaches the front of A, because B has traveled in the same time some distance here. So it travels this distance. Let's call it D of 1. Now from here again, the bird, once it reaches the front of B, it reverses course and it goes back. So in the meanwhile, A has traveled this distance here. So the bird goes back, and let's say this is D of 2. Now once it reaches the front of A, again it reverses course and goes back. So let's say this is D of 3. So on and so forth, as you can see, and it goes on until it continues this until the two trains cross each other here. Now as you can see, this becomes a tricky problem because you have to calculate the distance D1, D2, D3, D4. So we don't know how many passes there are going to be. So it becomes a tricky problem to solve. Now, the other way to think about it is, let's say that these two trains take time t to cross each other. So t is time taken to cross each other. Okay. So this is the time that the two trains take to cross each other. Now, if you think about it, the bird starts to fly as soon as the trains start from the station, and it stops flying when they cross each other. So the time taken by the trains to cross each other should be the same as the time taken by the birds to fly between those two trains. So the same time is equal to time the bird flies between the two trains. Okay, so the two times should be the same. The time taken by the train to cross each other should be the same as the time taken by the bird to fly between these two trains. Okay. Now we also know that, let's say this is the distance dA, which is the distance traveled by A, and dB, which is the distance traveled by B. So dA plus dB is equal to 1000 miles. We know that dA is the distance traveled before it crosses B, and dB is the distance traveled before it crosses A, and it should be the same amount of time. Okay, so dA is S of A into T plus S of B into T equal to 1000. So S of A is given as 60 times T plus 40 times T. S of B is 40, which is the speed of B, is equal to 1000. So we can say 100 times T is equal to 1000, or T is equal to 1000 divided by 100, which is 10 hours. So the time taken by these two trains to cross each other is 10 hours, or is the same time that the bird flies between these two trains. So we can say distance traveled by the bird is equal to speed of bird into T, or speed of bird is given as 80 miles per hour into 10 is 800 miles. So that's the distance that the bird travels before these two trains cross each other. And that's how you solve this problem. Rather than calculating the individual distances in each pass, we can just calculate the time taken by the bird to fly and calculate the distance. And thank you.